of a lot of ACA policies.
Involved with every single decision. That way lies madness. I have to empower my teams to make good decisions when I'm not in the room. I need to distribute decision making. Now, my job is to establish principles, to put the right guardrails in place so that teams make good decisions when I'm not there. And one of the ways that we can do that is leveraging the power of defaults. Defaults are a super, super powerful concept. This actually is what sits behind behavioral economics, and it's a fairly simple concept, honestly, but it was powerful enough that it earned Richard Thaler a Nobel Prize. Now, honestly, when you boil this down, it almost seems like, well, wait, isn't that like a kindergarten thing? How does that get you a Nobel Prize? But, you know, this is how it works when you're the first person to do it. If you want to get somebody to do something, you make it easy. Wow, shocking. And so one of the ways that this gets put into play, you know, in the United States, the way a lot of our retirement savings work is in a program called the 401k that companies can offer to their employees. For most of the existence of this 401k savings vehicle, you had to actively sign up for it. And I still remember one of my first few days on the job, my first job out of college, we had this HR orientation, and they made it very clear that, hey, folks, really, you should sign up for your 401k. And there's this big pile of paperwork, and it forces you to answer some questions that you don't know anything about. And, you know, I'm not an expert on where should my money be or how much money should I put away. It's out of my comfort zone. And a lot of people look at that and go, I'm just not going to bother. Well, that's not the right choice. You want people to save money for their retirement so that when they get to the point of wanting to or needing to retire, they can do that. Many, many, many organizations have switched that bit now, thanks, frankly, to the work of Thaler and others that say, no, we're going to default you into the 401k program. You have to take action to get out of it. And unsurprisingly, if you understand how human beings work, that skyrocketed participation in corporations' 401ks and ultimately has helped ensure that more people will have at least some amount of comfort in retirement. Now, as software people, we can use that to our advantage. And I understand some of you might be thinking, hey, Nate, why the heck are we talking about economics here? We can wield the power of defaults. One of the things that I'm always trying to do on projects is make the right choice the easy choice for my teams. Now, one of the other things you discover pretty quickly here is these distributed systems all have very similar needs. There's a lot of the same problems here. We don't want or need to reinvent the wheel. So we know we're going to need some monitoring. These distributed systems are much harder to reason about. You need good observability. There's going to be a whole new set of error conditions. We need to have something in place to make sure that when things don't go the way we expect, it doesn't blow up and people get, you know, some crazy error. Although I got to be honest with you, I take some amount of pleasure in seeing that on a website when I run into a stack trace of some sort, and I always get a chuckle out of that. I usually take a snapshot of it. I actually saw something recently on a website I was looking at. It was like a shipping site of some sort of, you know, tracking something that I'd ordered for my son. And it was a very strange message, but at the top of the page, it said index out of bounds, index 0 for empty list. And of course, as a geek, I had to take a screenshot of that because it made me laugh. We know we're going to have multiple consumers using our stuff, and so we want to make sure that we don't break them. So we want to take advantage of things like consumer-driven contracts. We might need a gateway to do rate limiting or to allow us to sort of abstract away where some of these things live. If we want to change URLs, maybe we want to use streams in sort of an event-driven approach. We don't want our configuration to be hard-coded. Maybe we decided everything should be a function. That sounds like fun. Everything has a service these days. Distributed systems, I don't know where this code is going to run, so I need something like service discovery. I'm going to have multiple instances of the service, so I need load balancing. I probably should document some of this so that the teams that come behind me have a chance of being successful. Now, again, I don't want every team to build these over and over and over again. That way lies madness, and that's how we get to this sort of suburban sprawl view of software that I really would rather not have. One of the things I greatly appreciate about Spring is it frees us as architects to focus on these critical things we have to get right to support the needs of our business, while giving my teams plenty of space to solve these critical business problems that they're being paid to solve. Now, to put it politely, there's a lot of ways to fail with distributed applications, countless ways to fail. What I love so much about Spring is it's here to help us. It's here to help your team. It's here to help your application and ultimately help everybody get a better night's sleep. Although I guess Jakob's going to fail at that one tonight. Sorry, buddy. The end of the day, this is about us delivering business value to production. That's what we get paid to do. put features and functionality into production reliably and repeatably. And I hope over the next few hours here, Jakob and I are going to show you a bunch of ways as to how that works. Now, I want to start by level setting on what the heck is Spring. The first Spring one that we did virtually, so this would have been 2020, the most popular talk, or the talk with the most attendance, was what is Spring? It was like Spring 101. I can't remember how Glenn titled it, but it was literally like Introduction to Spring. And this was a real eye-opener for me as just a reminder that there's a lot of folks who are new to the industry who have not grown up with these things. You know, I've thought a lot about this. You know, I sort of came of age, if it were, as Java was coming onto the scene. You know, I remember being in college and one of my professors was very excited about this new programming language called Java, and we were playing around with it one J term. That was like this month-long semester-y like thing we had in January. And I thought that was really cool. And then I got a real job, and you know, of course, we weren't using Java on that project, but we had a book club where we were learning about Java, and I was just super excited about that programming language. So when I had an opportunity to get on a Java project, I leapt at that chance and never looked back. So I've grown up with Java, and a lot of the changes that have happened to me were just sort of, you know, just incremental. And I forget that for many folks who come along later, it's like, oh wow, this is this huge amount of knowledge that you have to learn kind of all at once. And same with Spring. Spring's been around for a while, and so I had the good fortune sort of growing up with that as well. And so it's just good to know that it's important to remember that for many folks, this is the first time they might be interacting with Spring is when they get into their first job and their company's been using this for 10, 15, 20 years. End of the day, Spring is an integration framework, and it's here to combine a whole bunch of different things together and give us a consistent programming model in the Java ecosystem. And so it really started out of the JEE realm saying, boy, these EJB things are kind of painful. I think there's a better way. Now, it isn't just about Java. It does support Kotlin and Groovy as well. And it has really grown into this whole family of things built on top of the Spring framework. Now, one of the things that I appreciate as an architect is it gives me support for pretty much any kind of application architecture that I might be using at this given moment in time. So whether it's message-driven, a traditional web application, or a reactive programming, microservice approach, functions, etc., Spring has me covered, and it gives me a bunch of choices. One of the other things that I really appreciate about Spring is it never paints me into a corner. As an architect, I'm always trying to think, like, what are the different vectors of change? What are the likely things to change on my project? How do I make sure that that's not going to hamstring my application, not put us into a box? Spring makes it simple to swap things out. So if we start using one message broker and we get a little further into the project and realize, yep, that's not going to solve our problem, that's not going to meet all our needs, we can swap it out without having to completely rewrite everything in our application. If we need to use a different data store, that's fine. Again, we can change things without having to completely rewrite our application. I remember very early in my career, one of the big projects that we had going on at the time was switching out our data store. You know, it was actually going from a hierarchical database, this IMS database, which I'd never even heard of until I got into the real world. And we were going to replace that with a traditional relational database like DB2 or something, doesn't really matter. That's a massive, massive project. You know, I have no idea how long that took, but it was non-trivial. Of course, Spring didn't exist back then, so we can't blame Spring for that. The Spring folks work overtime, bend over backwards to be as backwards compatible as possible. Now, it doesn't mean you can run this on, you know, some ancient version of Java. I am kind of amazed how many folks are still running very old versions of Java. But it does do a pretty good job, I would argue, of staying with mainstream JDK versions and really minimizing any breaking changes. The APIs are really well designed, very thoughtful design. You know, they really are user-centered from the perspective of a developer. What does a developer expect? How does a developer want to interact with these APIs? You know, it's just, I think, really, really well done and put together. The code is also exceptional. You know, I know the team has worked really hard to keep high quality code. It is one of the code bases that I recommend to people when they're like, hey, how do I learn how to be a better programmer? It's like, well, take a look at well-written code. Spring is a perfect example of that. There's others as well. You know, I don't mean just to poke at Spring, but I also really, really appreciate the documentation. As an architect, as someone who spends a lot of time teaching, the documentation to me is so powerful and is often overlooked. I was having this conversation with Glenn Renfro from the spring team actually just last week. People just overlook documentation and how important it is. And when I'm getting started with something, you need to have that sort of hello world experience. That onboarding experience has got to be very solid. But then it also needs to grow along with you. And that's something that Spring does exceptionally well. They put a lot of effort into that. There's really good tutorials, and it doesn't all just come from the Spring team. I love the fact that you can Google pretty much anything in Spring, and you're probably going to find an example of it out there. Now, it has been around for a while. It first release happened back in 2003, and in software terms, that's like the Paleolithic era. And I do know how at least some developers approach anything that's quote unquote old. And some people seem to think old is anything that's, from 6 months or so ago. I don't think that's always the best way to look at it. I absolutely love this thread from Jeff Johnson. And it says, I get the sense that for a lot of programmers are afraid of the old, as if it's always arcane and complex, while the new is simple and elegant. And I understand where some of this comes from, because many of us, we first get into this industry, somebody kind of takes us under their wing and says, hey, make sure your skill set's up to date. You don't want to have one of those old skill sets. In case you need or want to get a new job, you want to be positioned to take advantage of that. So always make sure your skill set's up to date. And there's a lot of truth to that. Although there's good money to be made on the back end of a technology too. You just have to know when it's time to jump. Although I think of that a lot. COBOL's been around forever, at least in programming terms. I don't think COBOL's going anywhere. There are some languages that are just here to stay. And I would put Java in that camp as well. Same with JavaScript, frankly. So there's not going to be much to replace that ultimately, at least not not in a way that's cost effective. But Jeff goes on to make a really interesting point. He said, the reality here is the new is unfinished, buggy, and unproven, while the old is refined, stable, and tested. There's a lot to be said for refined, stable, and tested. Spring has been through the worst. Spring has the scars to prove it. It's going to work. And there's a reason why so many organizations continue to rely on Spring day in, day out for their mission-critical applications. I mentioned this earlier. This was built with the idea of making JEE development back when JEE had a 2 in it, J2EE. And it was trying to give us what EJB promised us without the pain of EJBs. I've tried to forget EJBs as much as I could. I want to say it came from a good place, right? There were good ideas there, just the implementation was painful at best. I did actually work with somebody for a while that was adamant that, if you're not using every ounce of EJBs, you're not doing it right, and blah, blah, blah. And it's all about enterprise. If you're doing enterprise applications, you absolutely have to use EJBs. Disagree. It's built around the idea of POJOs, plain old Java object, instead of EJBs, these sort of specialized Java bean-like things, although there really wasn't much bean-like, in my opinion, about EJBs. And it also takes liberal advantage of inversion of control, otherwise known as dependency injection. So the idea here being, rather than have this all hard-coded in, you inject your dependencies in your application so you can change them when necessary. And this to me is just an embodiment of the loose coupling that we're all striving for. I'm fond of saying that the zeroth law of computer science is high cohesion, low coupling. And so much what we're trying to do boils down to that. And this concept allows us to inject in maybe a test variant for testing purposes. Here's the production variant. Here's a different production variant, for a different situation. It's largely built around a declarative programming model. So you say, this is what I want to do, and then Spring makes it so. So insert your favorite Captain Kirk reference here, or I should say Captain Picard. All about eliminating boilerplate. I hate boilerplate. I've certainly been in some instances where people are like, oh, it's no big deal. Your IDE generates it for you. I don't care. I still got to look at it. I still got to drag it along. It still becomes this boat anchor that I have to deal with and maintain for the next, eternity, because software projects never seem to go away. Now, it has obviously grown considerably from its early days. And if you actually go to the Spring website, you can see just how much stuff is there. And it's actually a little overwhelming. And frankly, that was part of what inspired Joachim and I to put this talk together because we recognize there's a lot of folks, especially like me, who come from more the architecture side, who might be new to Java, might now be on a team that's using Spring and be like, I have no idea what's going on here. So hopefully by the time we're done here, you'll at least have a rough idea of what Spring can do, or at least know where to go to get some more answers. So Spring Boot is maybe sort of the newer kid in town, and I think this is what a lot of people think of when they say Spring these days. It's really just this opinionated view of Spring and making it as simple as possible to build an application. Now, there is some confusion here. Spring Boot is not itself an app server, though it does embed a servlet container. Right now, it's not actually implementing those specs, but it will configure beans as necessary to do that. Now, unlike some tools that we've used in the past, it is not, in fact, the code generator. All right, again, a lot of this is just declarative. It will configure beans on your behalf so that you don't have to. So instead of you writing reams and reams of configuration, you know, it takes care of that on your behalf. I still think one of the most important things that Rails gave us ultimately was convention over configuration. So many of these things are things that we have done by convention, and yet we still had to then go in and configure it. And so I give them a tip of the hat for bringing that concept into the equation. I showed you Spring Initializer already. That's start.spring.io. This is where you go to get your project started. This is where you can pick your language, pick your build preferences, what boot version you want. I guess I was trying to sound Canadian. Put in various project metadata, what other kind of packaging stuff you need, Java level, etc. And then it also allows you to select all your dependencies. Now, I remember one of my least favorite parts of Java projects back in the day was all around dependency management, trying to get everything right. If I need this version of this, then I need that version of that, and that means I can't have this version of that, and trying to get all those collisions to line up. Spring Boot solves that problem for you. So you go into the initializer, you say all the things you need. Oh, you're going to make reactive? Cool, here's some reactive stuff. Oh, you're going to use Neo4j? Awesome, here you go. Don't worry about making sure everything's configured properly. We've already done that for you. This will give you a starter project that you can then use to launch your application from, import that into your editor of choice, and you're up and running. And you don't have to worry about all the arguing we used to have around, well, what's our project structure going to look like? Are we going to have this folder or that folder? A lot of wasted time in my career arguing about things that not really matter. Now, you don't have to love GUIs. I'm a UI person because I wrote UIs for most of my career, so I'm always partial to that. But there is a command line version, and many editors actually have this baked in as well. So from there, I can go ahead and download that artifact, open it up, and now I'm ready to rock. Spring Cloud is actually something we're going to talk an awful lot about here today. As I mentioned earlier, these distributed applications share a lot of patterns. And so Spring Cloud is ultimately this umbrella project with a bunch of out-of-the-box solutions that help us deal with many of the common problems in cloud-native applications, whether that's working with a specific cloud provider, whether that's things like configuration, contracts, gateway, etc. An awful lot of stuff here. Right? So this is where a lot of the useful defaults are going to come from if you're building these distributed cloud-native applications today. Now, we're not here to own your cloud. We don't care. You run this wherever you want. We certainly get along well with, I think, all the providers. I've certainly seen us do a fair number of things with Azure these days, but that to me is just because Josh knows a couple of their folks fairly well, and so there you go. But we'll run on any cloud. As long as Java runs there, we're pretty darn happy. So start with start.spring.io. This is where you can go to get your externalized configuration. And it also integrates with a fair number of things that come out of the Netflix world. Netflix obviously has a lot of experience in distributed allocations. They're quite good at it. And so we can integrate with that quite well. So everything from security to tracing. If you want to do event-driven, which is a whole other can of worms, we'll talk about that later. You need to have deployment pipelines to make this work, discovery connectors. There's a lot here. Again, we're definitely going to dip into that topic. There's also Spring Data. Now, this is a Spring approach to data access. I love Spring Data, largely because I was just bad enough, I guess, at SQL that they wouldn't let me write SQL on projects. And so I was always kind of relegated to not doing that part of the application. And luckily for me, one of my teammates at the time was really, really good at SQL. And so he handled most of that, and I handled most of the front-end stuff, and everything's good. So I love the fact that Spring Data just sort of like frees me from having to worry about all that, and will let people who are much better at writing all those wonderful inner and outer joins just do their jobs. I also really appreciate that it's trying to give us a consistent programming model across all of the different types of data stores we have today. You know, I like to joke that I'm old enough that when I started programming, we had both kinds of data stores. We had relational and we had hierarchical, and we loved it. And we got everything done with that. And I actually had this conversation with Jim Weber of Neo4j on my Twitch stream. This was earlier this year, just kind of talking about like what fueled this explosion in alternative data stores. You know, it used to just be, you can do everything in relational. And then the NoSQL movement happened, and we started getting all sorts of different data stores. You know, and I think that's pretty darn cool. And it's interesting how we seem to have kind of settled on maybe half a dozen or so that we typically use sort of project in, project out. But just because we have all these doesn't mean they're the right choice for every project. This is where you've got to use your experience, you know, and hopefully you've got somebody on your team who can help you make that determination. I see way too much resume-driven design in this industry where people pick something because they want to put it on their resume. So Spring Data gives us broad support for a whole bunch of databases. Now, I'm actually going to pause at this point, and I am going to stop my screen.
10, 15, maybe 20 times I'm in this training, both online, on-site, in different places. And I must say, I really love the intro you did. I always listen to that, and I always enjoy it, so hats off. And now I'm here to code, so sleeves up, and I will try to do a demo with Spring Boot and Spring Data so that you all can see what it looks like. Maybe you will have some questions. Hopefully the demo gods will be with me today. It's 2 a.m., so I don't know about them. This is start on Spring.io. Nate mentioned that. You can configure your language in here. You can choose your favorite build tool. You can choose the Spring Boot version and some project metadata. You can add dependencies. So what's cool about Spring Boot is that it makes it very easy to create standalone production-grade Spring-based applications with powers of default. The applications that just run, you will see how in a while. So, for instance, most probably, if I'm about to build a web application, an enterprise application, I will use some sort of database. If it's Java world, maybe I will use JPA to connect to my database. If you don't like JPA, there are other APIs that serve as object or relational mappers, but most probably you will choose some ORM. Or maybe if you don't like ORM at all, you can choose just pure JDBC if you want. So as Nate mentioned, we have plenty of options. So let's say for the sake of this demo, I'm going to choose JPA. But that's not enough, of course, because JPA, it's as you all know, database agnostic. So I'll have to choose a specific driver, a specific database. Let's pick H2. So with those two dependencies as my options, my POM XML will look like this. Or this is Gradle because I chose Gradle. By the way, it's night, so I will switch to night mode. Why not? Let's choose Maven one more time and explore the project. As you can see, I have data JPA, I have H2, and this is exactly what I did while Nate was talking. I downloaded the project, and it looks like this. I have two different dependencies in my POM XML, starter data JPA and H2, which means we are able right now to connect to the database because, as it was already mentioned, Spring Boot leverages the powers of default, and by default, H2 will try to connect to set up an in-memory database. Of course, if I want to change that, it's super easy. I will just need to pass some configuration, some properties in application.properties file, which is here, as you can see. I will talk about those properties later on. But anyways, right now, with those two dependencies, I'm able to connect to a database. But let's actually store something in the database. Let's pick, I don't know, a financial domain for our demo today. Let's imagine that we have credit cards. in our database. Let's imagine we have a table which is called credit card, and we want to map it to our application-based entity. To do that, I will use an annotation called @entity that comes from JPA, as you can see. JPA entity, they need both an ID. They also need the value for that ID. I will take a generated value. They need an empty constructor, which is here by default. I will create another one soon. Let's say we have some more data in here, like for instance, balance in big decimal. I know big decimal not the best way to store money because it doesn't have currency, but for the sake of the demo, let's imagine we just support one currency. So big decimal for the sake of the demo. All right, what else? So now let's imagine I want to store, I want to fetch credit cards, maybe by balance, maybe by ID. I want to fetch all at once or whatever. So I would like to run some SQL queries. To do that, probably it will be almost the same in many applications. What differs is the name of the table, the name of the column you want to fetch by, and so on and so forth. That's why Spring Data comes with JPA repo that you can extend, and you will get many different methods for free, like find all by ID, save all, save and flash, delete in batch, get one by ID, and so on and so forth. I am able also to create custom methods, which you can see in a while. By the way, I think it wasn't already mentioned, but Spring and Spring Boot comes with testing support. I would like to say even that testing is like first-class citizen in Spring ecosystem. So whatever you do, if you want to connect to a database, I mean the data layer, messaging, MVC, web layer, integration, whatever, you can always test everything because almost every part in Spring comes with a testing support, which is very cool, which is very easy to use. For instance, I can set up a test which first saves some credit cards with a specific balance, 1 and 20, which means I need a new constructor. Balance, this balance equals balance. Now I need an empty constructor as well because JPA requires me to have one. All right, let's go back to the test. As you can see, I have two different credit cards in my database. Now I want to fetch, let's say all. So I'm using the default method provided by Spring Data, and I will store the result in the collection called all. And now I can assert. Probably I need to assert that the size of the collection is equals to 2. Let me run this test, and as soon as it's green, hopefully it's green, we'll try to do some custom query, because find all might not be the most common use case you would like to use. As you can see, the test is green without me having to code anything beside the name of the entity and some columns by fields. All right, so let's, for instance, imagine that I want to fetch credit cards with a balance greater than X. X being equals, for instance, 5 or 6, depending what you pass. So this is something like this. Select from credit cards where balance equals or greater than 5, let's say, or X. I don't want to write this SQL query every now and then because it's kind of repetitive, and it's something that probably I will use in a different project, in a different domain. What changes is the name of the table and the name of the field. That's why Spring Data JPA comes with an embedded support for that. For instance, I can return list of credit cards because I expect there might be multiple credit cards with a balance greater than X, maybe 0, maybe N. Find all by, as you can see, my IntelliJ even gives me hints that I can query by balance. I can query by balance greater than, for instance, or maybe balance for, between, containing, contain. So anything that you can actually do with SQL, you can have also strongly type in our Java world. find all by balance greater than was the thing we wanted, then X. So this is it. Spring Data API is going to translate this query, this method signature to this query. And let me try to show that. Maybe there is a bug, maybe there is a typo in this method, but I don't see one. Find all by balance greater than, but anyways, we'll see that during testing. Find all by balance greater than X, X being equal to 5, greater than 5. So I suspect this query should return one credit card, right? Because only that one actually meets our needs. Let me run this. This is, by the way, event section, and see if it's green. Hopefully it's green. So with Spring Data, it's green. With Spring Data JPA, you can actually type different queries. You can find by 2 fields. You can do whatever you would like to do. Probably, normally you do it writing manual SQL statement, query, or something like that. But with Spring Data JPA, you can use a strongly typed method. By the way, Spring Data JPA is a part of the larger Spring Data family. Spring Data makes it easy to implement, as you can see, JPA-based repos. But the model also deals with support for, I don't know, MongoDB, for instance, Cassandra, Redis. So not only relational DBs, connecting to MongoDB is as easy as this. What you have to change is the dependency that you have. Instead of Spring Boot Starter Data JPA, you would have Spring Boot Starter Data Mongo, and then you will have different kind of then your credit card wouldn't be the entity, it would be a document, right? And the repo you would extend would be probably, if my memory serves me well, Mongo repository or something like that. I don't remember. But the API almost looks the same. The usage, the job you have to do, the work that has to be done, it's almost the same. So you can use different data layers depending on your needs. All right. I think that's it. That was easy. The test was green, even though it's 2 a.m. First test was nice. I will hand it over to my friend Nate.
You can do that all on demand. I know I have spent more time than I care to admit trying to think through, like, how much capacity is my app going to need? And, oh no, we got super popular, super successful. We don't know what to do now. We're come to a screeching halt. Compute is just a very different story today than it was when I first started building apps. I have limitless compute with a giant asterisk that says, like, additional fees may apply.